Aloha! It is March 11th, 2026, and I am joined by Andy, Beth, and I'm Junmi, and this is the Daily AI Show. Today, we're going to cover a whole bunch of AI news, and then I've got a little bit of an AI in science story for you. So let's dive in really quickly. And Andy, what story do you have for us today?
Well, I want to lead off with, the question of just how popular is AI? Like, we see the huge numbers that of people who are using it, but a new just this month poll by NBC News of 1,000 registered voters showed that there are only two items on their list with lower negative net ratings than AI. And so I'm sure you're just wanting to know what those two things are. They are Iran and the Democratic Party. Those two have had the biggest difference between the number of positive people who are voting positive on that particular subject and people who are voting negative. But there's some others around that same cluster at the bottom of the list that I thought were interesting. One of them is ICE. And that doesn't surprise you. It's way down there, but AI is below ICE. ICE has a negative 18 difference, and AI has a negative 20. So, wow.
Okay, but the neutral, there was a big chunk of neutral feelings about AI where there wasn't so much about the war or ICE, I thought. But yes, in the absolutely no.
Yeah. So yeah, lies, damn lies, and statistics. There we go. So the poll does require further interpretation. Frankly, I like AI. I don't know what they're talking about. But a lot of it has to do with the lack of knowledge about what the positive benefits are of using the full range of, frankly, inscrutable tools that are available to us, and the threats to society and otherwise. So I can see why overall for voters, AI is a negative issue.
Well, it could also see, for me, my experience of people who are younger than we are, it feels very wrapped into, like, the dislike, absolutely not, feels very wrapped into climate and what it's doing to the environment, right? Which is also a runaway story. So the idea of what it's doing to the environment has a seed of truth, but is interpreted, I think, more than it actually turns out to be. That doesn't mean that it won't turn out to be that, right? But it feels a little more like they're pretty clear on what the benefits. That's wrong. If you're not using it every day, you're not clear on what the benefits. But that the pushback isn't about the benefits. The pushback is about environment.
I think just stepping back, it's interesting in my lifetime that, if we looked at a snapshot of what the important voter issues were, both positive and negative, across the decades, I didn't foresee that artificial intelligence was going to be so omnipresent in the news and in the dialogue around what's happening in the world. It's really front and center, whether it's in respect of war and the application of AI to war, or it's in the context of the significant income disparity that's emerged since the 1970s and so on, and being accelerated by AI. All of those things, AI is touching on every one of those things now, and it's really centered. It's a centerpiece in my life, frankly, now, and I didn't see that coming.
No. And you saw all kinds of things coming, Andy.
I thought I did, but I certainly wasn't able to take advantage of them.
Right. Beth, do you have a story that's of particular interest?
I do. So, we have shared Yann LeCun's vision or pushback on AI and large language models many times on this show. right? Like he's fairly famous saying that the large language model isn't as smart as your cat because your cat has a sense of the world. And he also, this was recently that he left Meta, right? The confirmed leaving after the scaled person came and took over AI at Meta, not Brian's scaled person.
Alex Wang, yeah.
You. So, Yann LeCun's advanced machine intelligence just emerged, so that's his company, with a 1.03 billion seed round. He's a Turing Award winner. I'm reading this from the rundown. So he left in November after 12 years with Fair, telling Mark Zuckerberg he could build world models faster, cheaper, and better on his own. So the seed round is significant at 1 billion basically, but the other significance is that it's the biggest seed round and investment in Europe at this point.
Yeah, he's over in France. He moved from Meta's headquarters, I think, or maybe he was working for Meta from France, but he's a French guy.
Yes.
Yeah. And by the way, the valuation that the investors gave that company, which hasn't done anything yet, although behind the scenes, I'm sure they've got a lot, it's $3.5 billion. So it's a unicorn before it ever starts. It's a unicorn in the money provided as the seed funding. How do you spend $1 billion, on developing world models? Well, NVIDIA can tell you, because they're building world models and they spent way more than that.
And NVIDIA is part of the backers. NVIDIA, Samsung, Bezos, Expeditions, Eric Schmidt and Mark Cuban are among the backers. The headquarters is in Paris, and that's interesting because we had a little tour when Brian was in Paris of like an incubator that was it was a converted railway station, if I remember. So
that's right.
I'm not saying that he's there, but I'm not saying he's not there, and that would be very cool. And we're starting to see posts of people saying, "Hey, I'm pleased to announce that I'm going to be working with Yann LeCun at Advanced Machine Intelligence." So very cool.
Yeah.
Karl's joined us. So Karl,
Hey,
do
Karl.
you feel? I'll throw you into the deep end. Do you have a story that you want to talk about today?
Oh yes, I do. Hold on, give me 1 second. There was something that I posted yesterday to the chat, and I thought it was very funny. Hold on, let's see if I can play it. Yeah. Okay, so I want to play this, and you let me know what you all think of it. Okay.
How many tokens a year is my employer getting from me in terms of productivity?
Let me run the math real quick. Assuming you're a full-time human, 40 hours a week, 50 weeks a year, that's about 2,000 hours. If we figure your brain's doing 20,000 tokens a day, like we talked about, that's roughly 100,000 tokens per work week. Multiply by 50, 5 million tokens a year. So yeah, your boss is basically getting 5 million little thoughts, decisions, emails, and why is this spreadsheet broken again moments for whatever they're paying you. Kind of makes you wonder who the real bargain is, huh?
So 5 million tokens a year they get from me. What is the cost of getting 5 million tokens with AI right now?
Right now, March 2026, prices have dropped hard since last year. For 5 million tokens, depends on the model, but let's keep it real. With something like OpenAI's GPT 5.2, their current top dog, you're looking at about $9 for input-heavy work. Say 175 million input, 14 output. If it's half and half, call it $12 to $15 total. Cheaper options? Grok's Fast tier from XAI is stupid cheap, like $1 or less for 5 mil if you're mostly prompted, not generating numbers. Claude's still around 3 to 15 per million, so maybe $20 tops for a balanced run. Bottom line, your 5 million human tokens a year, and AI could replicate the raw output for under $20, maybe 5 if you go budget. Makes you think, are we the expensive part now?
Anyway, so yeah, that was literally.
Yes. That's a good one. Thanks for finding that. That's excellent.
So it was like, well, then I thought, hold on a second. The big arch is worth more than $9. So the new McDonald's sandwich is worth more than my entire output for the year.
I don't know. I think there's something wrong with the token math there. A token is a smaller atom, if you will, than a completed thought. I think there's a lot more tokens being generated than 5 million in a year by a human brain.
Well, I mean, there's a reason that everybody's trying to figure out how to power AI at the efficiency of the human brain with selective recall, with auto pruning recall, right? Our memories and yeah.
Well, that was fun. I was very entertained by that. Especially though, if you were just listening to us and you couldn't see the face expression of the guy who's asking the questions to the AI model, and I don't know which AI model it was. I've never heard that particular voice before. Anyway, his expression was really wonderful. He acted that one out beautifully.
Yeah.
It was also created by AI and not edited because 5.2 has not been the premier model for since the training data, like many models have happened since the training data stopped, right?
Right.
Or it's an old one.
Well, speaking of how AI can do more things more efficiently and with less tokens, I wanted to talk a little bit about Andre Karpathy's auto research. Have you guys covered that at all?
No,
So, a couple. This came out. I think he released it like on the 8th. But essentially, so what he did was he open sourced a project called Auto Research. In his X post, he got 8.6 million views for this, and the GitHub repo has crossed 8,000 stars in the last couple of days. And so the implications are, pretty big for a weekend project. So what he did was he created a 630 line Python script, and you give an AI agent a language model training setup, but it's for a single GPU, and you just point it at this training script and go on with your day. So the agent modifies the code, runs a 5-minute training experiment, checks if the model improved, keeps or discards the change, and repeats. So by morning, he had roughly 100 completed experiments, and he didn't have to touch anything. So the way he puts it is, the goal is to engineer your agents to make the fastest research progress indefinitely and without any of your own involvement. Now, what happens next is pretty interesting. So a company called Hyperspace AI distributed the loop across a peer-to-peer network. And on the 8th, 35 autonomous agents ran 333 experiments unsupervised. The interesting finding, the agents on powerful, he released it on powerful H100 GPUs used brute force to find aggressive learning rates, while agents on weaker laptop hardware got more clever. They focused on initialization strategies and normalization choices. So different hardware, different optimizations, both seem to work well. At the same time, Shopify CEO Toby Lutke adapted the framework overnight and reported a 19% improvement, with the agent optimized smaller model outperforming a larger model that had been configured manually. So why does this matter? This is AI doing AI research. It closes the loop. Researchers have been theorizing for years. AI improving the very training code that produces better AI. And because it's 630 lines, open source, it's under the MIT license and can run on a single GPU, anyone can run it. So not just big labs, anyone with a graphics card and a markdown file. The human's role shifts from experiment to experimental designer. You define the problem and what better means. The agent grinds through the search space while you sleep. So in terms of ML research, developing better AI, you can have your AI developing better versions of itself. And you can do it on a single GPU. That was the thing that shocked me the most when I read about it, is that this is single GPU ML research, and anyone could do it. I could run it right now on my own GPU.
So I have some questions about what the actual setup is. There's 630 lines of Python code. That's a little package. And then there's a GPU. Now we've talked about those two components, but there is not an agentic, LLM thing that's working that set of 630 lines of code. What's being improved actually? Is it the 630 lines of code that self improves, or is it an LLM that's getting improved, like a local model that you're basically giving the task of the improver, the 630 lines to kind of move forward?
Right. So the script is running the loop of ML experiments. So whatever your experiment stack is to start developing your LLM or your other ML based AI model is what this is running. So it's doing the improvement, that improvement loop or that improvement stack for all of your experiments. And so if you've done ML research, you're just going to have this huge list of experiments that you're trying to run on on whatever model you're trying to build, and improving it from there and there. I think the key takeaway is that you're doing AI. It's an AI self-improvement loop. It's tiny and runs on relatively insignificant hardware requirements.
Right.
It's got like a new fine-tuning approach to a model that you may have running locally. Yeah, you have to have a local running model because you can't change the parameters on a cloud-based model unless you have an isolated instance somewhere in the cloud. Am I right about that?
Yeah, you're not like you're not improving a like a chat GPT or a GPT 5.4 or whatever. This is more for building your own models.
Yeah.
But it's a tiny model. Well, because this is when I talked about it with Grok and on the show the other day, Grok referred to it as a toy lab, right? So you're not even necessarily able to do something in like a general language model. Although it may be that JG chaining and doing other things like Jumi just said makes that more possible. So in a follow-up post on Monday, March 9th, Andre said, 3 days ago, I left auto research tuning nano chat for about 2 days on depth equals 12 model. And it found 20 changes that improved the validation loss. He tested the changes and all of them were additive and transferred to larger depth equals 24 models, right? So he's doing the research on a tiny model. It can move to it's generalizable, or it can move to the larger model, and stacking up all of the changes. Today I measured that the leaderboard's time to GPT-2, which is an internal measure, I'm sure, drops from 2.02 hours to 1.8 hours. That's an 11% improvement. So that's the kind of results that this could give you, and then you can make the inferences not not AI inference. You can make the assumptions or do the tests from the small test to the larger test and then see improvement being stacked. And the real key for this is that he says, I'm very used to doing the iterative optimization of neural network training manually. You come up with ideas, you implement them, you check if they work. Better validation loss. You come up with new ideas based on that, and you do that. What he did in leaving it alone, he was very surprised that on top of the tuning that he'd already done over a good amount of time, this was so successful.
Mhm. Cool. Yeah. Prometheus Unbound.
Yeah, those first steps, anyways, right?
Well,
Does anybody? Oh, go ahead.
we're on the slide, right? I mean, when we talk about Prometheus, we're like, okay, so it was this, and then boom, it was super fast. But there was a slow ramp up to the curve. You just didn't notice that it was the curve when the ramp up was happening. It's like, oh, this is interesting. Why does that matter? Oh, there's a lot of talk about self-improving agents with persistent memory, right? Those are the things that we're talking about. That is the starting of the descent before the boom, I think. Do you agree, Andy?
I see that there's probably a tipping point that's coming where, the rapid acceleration of addition of context retention in the form of persistent memory, and also self-improvement reinforcement learning techniques like those 630 lines of code for tuning a model
Right.
combined to really rapidly advance the capabilities toward AGI.
And the Anthropic just 4 hours ago introduced the Anthropic Institute on that note because to facilitate and seed conversations about powerful AI, because we believe being forewarned is being forearmed. The Anthropic Institute will tell the world what we are seeing and expecting for the technology we build. It will lead to new research into the challenges posed by more powerful AI and partner with others to address them. This is a little bit like a follow-up to their relationship breakup with the Department of War. But also, I think that all the labs are kind of saying, hey, everybody wake up. We just need to have a little bit more of a conversation about what's possible now and what we see coming in the relative near future.
And so weave off of that story. Have you talked about the OpenAI robotics leader leaving their
No.
OpenAI? Okay.
We had it teed up, but yes, it's a relevant story.
So on Saturday, Caitlin Klonowski, the executive leading OpenAI's hardware and robotics team, publicly resigned. Her statement was direct. AI has an important role in national security, but surveillance of Americans without judicial oversight and lethal autonomy without human authorization are lines that deserve more deliberation than they got. She clarified in a follow-up, my issue is that the announcement was rushed without the guardrails defined. It's a governance concern first and foremost. So a little bit of the context. In days before, the Pentagon had been negotiating with Anthropic about deploying AI on classified networks. Anthropic pushed for strict limits, no mass domestic surveillance, no fully autonomous weapons. Those negotiations collapsed, and then Pentagon did something unprecedented. It designated Anthropic a supply chain risk. That's not symbolic. It could force companies like NVIDIA to sever commercial ties with Anthropic. Anthropic says it will fight the designation in court, which has happened. Then very quickly, OpenAI announced that its own agreement allowing its technology into classified environments. Even CEO Sam Altman reportedly acknowledged the rollout appeared opportunistic and sloppy. Kalinowski's departure is especially significant because she wasn't a policy person. She led robotics and hardware. when the person running your robotics division resigns over concerns about lethal autonomy, that's someone with direct line of sight into what these technologies can do, saying the process wasn't right. An OpenAI spokesperson said the agreement creates a workable path for responsible national security uses of AI, with red lines against domestic surveillance and autonomous weapons. The bigger picture. The Anthropic supply chain designation sends a chilling signal to any AI company that might want to negotiate limits on military use, and Kalinowski's resignation sends a different signal. The people inside these companies believe the pace of deal-making is outrunning the pace of governance. So, a significant move. As we've seen over the last months or year, and this might be due to the limited talent pool or because of Meta's, enormous sums they've been throwing around. The leaders and talent of these programs do have a spotlight on them. So anytime one of them makes a move, that becomes a significant bit of news. And the why they make the move becomes more significant as well. So to have the head of OpenAI's robotics team say, hey, this is not done correctly and I'm out of here, I think is a big step in saying, okay, well, it's time to reevaluate because the people working on the stuff doesn't seem to align with what's happening outside of their work. Direct purview.
Very interesting. So Gwyn asked a question here in the thread. It's saying, do you think there's something going on with the type of boots on the ground there will be? And I think you're talking about the possibility of autonomous killing weapons that are robotic. And we have those in a sense in the form of autonomous drones that are pre-programmed to, take action in, battle space. But it's a very fearsome concept of the idea of having, really fast moving humanoid or dog type or other format robots being able to rapidly dominate the space that's beyond the line of advance in a military confrontation, right? Or let's just say, what if China unleashed autonomous killing robots that, didn't have a whole lot of discrimination, but were just designed to kill anything that looked like it was wearing a military uniform in Taiwan, right? And just release them and let them go. That's really scary, because these machines can move much faster. The things we've seen in Star Wars, and, the drone armies marching very slowly, that's not the way it's going to look, right? These things will be very fast. You've seen the dancers, the humanoid robot capabilities already, the dancers on stage, they can outperform the human dancers. They're not going to be dumb droids. They're going to be very, very fast and accurate, and it's going to be scary. And it's a whole new level of human confrontation that's possible with this. So yeah, I think that someone working in robotics inside OpenAI saying, no, I really can't sign up for this. That's an important demonstration of an ethical red line that, that person has against, involving themselves in the forward development of these kinds of capabilities.
Right. I think also the boots on the ground is referencing the talk that's coming from the Department of Defense and the president of we're looking at boots on the ground in the war in Iran.
Yeah. Well, moving on from the doom and gloom, I wanted to just mention to everyone who's been waiting for Google to come forward with additional tools that will improve their abilities to hopefully catch up with and match the abilities of Claude and Excel. Google has just released what they call context-aware generation, across the entire Google workspace. So in docs and slides, Gemini can create full drafts or design, aligned presentations using your own files, your calendar, and web data. It'll go out and search for you and then build these documents. In Sheets, it will populate missing fields for you. It'll use web data to get that information if necessary. It'll also automate tools that build entire dashboards from a single prompt. So you can now talk to Gemini. I've not tried this yet, but I'm grateful that Google is finally coming forward with some additional tools in Sheets, because I've tried to move away from Excel and work only in Sheets in order to sort of centralize both my storage and my context, as Google would say, around sheets that are actually operating models, for various tasks that I do. So it'll do cross-file analysis, meaning it'll provide you with answers and summaries with direct citations across your full set of documents, whether Sheets or Google Docs or slides. So you can start to ask Gemini now things about, and ask it to act on and change those files in your Google Apps suite, now called Workspace.
All right.
And they also dropped yesterday, or announced yesterday, the embeddings model, multimodal embeddings, which is being able to process video, audio, text, image. It made a specific it called out specifically the ability to process PDFs, right? So not just text and image, but text with image. The multimodal is supposed to have enough understanding of the various ways that information is communicated in those modalities that it can do a comprehensive analysis.
Yeah, so this is a capability that was developed at DeepMind, Google's division for really advanced research, and what that enables is embedding into a retrieval database all the different modalities. Like, so you have video and audio, and anything that you put into it is semantically clustered, so that they're all the retrieval of data is both text and video, are all, not both, across all of those different modes. And what is very interesting, and Brian will be very interested in hearing this, is that this allows developers to build search tools that could find, for example, find the moment in a video that matches this text description. And so now you've got a single vectorized data store that has all the information semantically coded in very high dimension space. I saw something about, with this new embedding model, it has a clever way of reducing a 3,000 plus dimension vector space down to 1,500, which is the typical sort of maximum dimension space for vector databases. So anyway, that's really an important development, especially with respect to our current project Bruno, which has a video search capability built into it. And we're currently using Gemini as a way of doing that, but I'm not certain. What the vector database is that Brian's implemented. So we'll have to talk to him about that. But this is important news to that project.
It's and it's the atomization process. The slight caveat to that is that it is $12 per 1 million tokens input. So, and I'm not entirely sure, 1 million tokens, we'll find out, because we're totally going to do it for the show. But what does that mean in terms of a show like ours with,
so what does a 1 hour show cost in tokens embedded? Yeah.
Right. Because right now, using the levels of Gemini that we're using, that I'm using with the atomization that I do afterwards, that is under $1 And in fact, the atomization itself is like, I don't know, 15 cents maybe. But what else? The other thing that I learned was that it looks like basically you're paying the highest that you need. So if you are processing a video that has audio and a screen that has an image with text on it, right? Like a PowerPoint or something like that. You're paying the $12 per the million cost, not also processing audio, not also processing these other things. And I'm sure the semantic, like understanding of what's happening on the screen as well. So more experiments to come.
Yep, always something new, and it really does bring up the Andy. What was that term about just waiting for the technology to get advanced?
It's called the weighting equation.
The waiting equation.
Do you have a overall more economic result and faster result by waiting for the technology to catch up rather than investing early on in the cycle?
But you should still be using the technology, right?
Oh, well,
Sure.
Yeah,
Rachel,
I mean,
Rachel Woods had a post, I think on LinkedIn the other day, which is probably a week ago or 2 weeks ago, but saying, I cannot imagine being the company or the person now who's looking at what's happening and saying, I'm still going to wait till it stabilizes, right? Like, I'm going to wait till everything's decided and then I'm going to jump in. And how, like, what a learning curve you would have for that.
oh, absolutely. Like just getting started now as opposed to having a year in or more. Yeah, I think conceptually just understanding those foundations is probably that biggest hurdle. I wonder, I guess this would be a question for chat or any of our viewers later is, if you are new to AI, what has been the largest hump or the most difficult, learning curve that you've had to experience? Because I think I still imagine in my head that, like when I was first getting into it, it was just the trying to deluge myself in information and then just constantly learning more and more and spending large portions of the day just absorbing enough to then start making forward steps. So I'm wondering if that's still the difficult part of getting into AI is that, okay, I need to do a lot of reading. I need to do a lot of watching of YouTube videos, and I need to go back and watch all 678 episodes of the Daily AI Show to catch up. Which you don't have to, but we'd like it if you did. So, right. So before I move on to AI and science, I just wanted to check if there was any other stories that either of you wanted to cover.
Yeah, I have something I can probably knock out in a couple minutes. This is around the idea that you get better results if you, as a marshaller of all of your AI resources, involve multiple models in the approach to whatever it is that you're doing. And I've talked about this on the show previously about vibe coding and using Gemini as a coach in working with Lovable's, Claude-based coding agent. And the combination of those two is better. And I've actually had recent experience where Lovable actually did something that Claude code didn't quite fully understand. And I couldn't quite figure out, because it's not transparent on Lovable, what it was that Lovable's multi-agent approach was doing that got to a better result than what Claude Code had proposed. And Claude acknowledged, oh, that's a much better idea, right? That kind of thing. So I have them talking to each other. Well, there's a company that is a Boston-based startup called Collective IQ. Collective meaning multi-models. It started as a platform for enterprises in the procurement space. And what the CEO of that procurement company felt was, and he's very technically proficient, obviously, because he started this startup that has a really incredible capability available now to do this collective IQ approach. He found that it was really constraining to have to decide on a single model. Like, "Oh, I'm going to be a Chat GPT person and I'm going to use that model." It was much better. They got better results when they had this sort of collaboration happening across models. So they unveiled this new product that they're offering to enterprise called an AI consensus platform. And it's designed to simultaneously query ChatGPT, Claude, Gemini, Grok, and up to 10 additional large language models before synthesizing the result into a single annotated answer that shows where and it doesn't just go and get individual answers. It actually it coordinates a dialogue across those models. So one model can be acting in a role that, challenges another one and also offers its own result. So it highlights then for the user where the models agree, it flags the disagreements, and aims to reduce hallucinations and bias that plague any single model approach to work with AI. So I just wanted to say, this is why I have so many subscriptions to different AI models. I don't want to give any of them up because I feel like each one of them has something to offer.
Right. Because some things each model has its own sort of expertise or seems to work best in a given situation.
But
So just go ahead.
And we also know that from giving another model what a different model has said, you get a different level of conversation, right? The same as if you put 5 people in a room to have a conversation about a topic, that's different than going out and doing 5 separate conversations, right? There is an additive, maybe a little competitive process of like, no, well, if they gave you that, I'm going to give you something just a little bit better, right?
So Andy, how would we best implement this? Would it be just an extra step in our questions that we're asking these models?
Well, I think what Claude Co-work has made possible for me is eliminating the necessity of copying and pasting things from Gemini back into, Claude or vice versa. Instead, now Claude Co-work can look at all of my transaction and interaction with Lovable, for example. And I just say when I want to get advice or perspective or new plans from Claude Co-work, I just ask using Whisperflow. I ask Claude Co-work to look at my most recent conversation, and it will then scroll through the entire thing, and it digests that very rapidly within 10 or 15 seconds, and then says, "Okay, here's what I think you should do," or this is what I would do as an approach. And so I'm Co-work to TLDRs, Co-work's automating the conversation with anything that's open in a browser for you.
Yeah. There is, I just want to drop one more thing. And one of the things that's very cool about what's happening with social media is that I can read tips from people who posted in a different language, and this comes from Deep Dive, who posted originally in Korean, and basically what they're doing is telling Claude sessions scrape all my Claude sessions stored on this computer, organize the tasks I do frequently, classify which ones would be good to put into skills, right? Repeated prompt collection, plugins, external integration, agents, autonomous agents, or Claude MD, and then make those, right? If it's a repetitive task, it can be automated, and auditing your own use, Andy, right? Like that's very much in line with what you're talking about.
Yeah.
And how cool, right?
Yeah, yeah. No, that's super interesting. I'm always interested in ways that I can make my own day-to-day easier or automated, I guess, in this sense. Um, just as a complete side note, Andy, I know you were saying you used Whisperflow. So I found an open source project which I really like called the Whispering. Um, so not as polished as Whisperflow, but it gets the job done, and I've been using that this weekend, and that's that's been an overall improvement on my interaction. Though I am kind of a little irritated with Anthropic and Claude because I keep on hitting my limits. What's going on? Shouldn't I be able to work all day without having limits?
By the way, that's another one of the advantages of using multiple models. So I'll often just pass it over to another model if I'm starting, if I'm fearing the approach of either a compaction or a strict limit. It's been a while now, I'm not spending hours at the terminal, my terminal, my workspace. I'm not spending hours at it. I get it maybe in bits and bits here. I get maybe a total of 2 hours a day outside of all of the other responsibilities I have. But I can get a lot done in 2 hours, especially when I'm using multiple models and I'm spreading the token limits across multiple models.
It's true. It's true. It's probably my own fault for wanting to use Opus 4.6 thinking for every single question. But
And thinking high, like
yeah,
thinking medium. I was like skating along on thinking medium and had several conversations like, what? Why would I tell you that March 10th is a Tuesday? Do you tell me that March 3rd is a Monday? Let's just talk about that, right? Like, let's just have some perspective conversation. And the answer is training data more than not doing date math.
So Junmi, you'll be interested to know, and perhaps you missed it because we only mentioned it in fast passing on the show, but in benchmark performances, in agentic coding, Sonnet 4.6 matches or slightly exceeds Opus 4.6. So at least in my use case, I use Sonnet. I don't use Opus at all.
well, that's probably the comparison I need to do. I've been doing a lot of replicating of systems or projects that I've created in ChatGPT, and I've replicated them over into Claude to see what kind of differences and if I can get better answers, through that process as well. So setting that stuff always takes up more time because you're asking these more in-depth questions like, oh, I have 300 source files to upload. You can only take 20 at a time. Okay, well, let's start absorbing it. Yeah. Also, by the way, if you haven't already, if you try and export your data from OpenAI, it took me 3 days to get it. So just as a note. Was it?
What did it take you? 3 days to
3 days. 3 days
For what?
to get an export of all of my data from OpenAI.
Oh,
Yeah.
okay.
So
Just because there was
finding-
so much data there.
yeah. I'm sure the process is also a low priority on their, list of things for compute. But just as a note, it could take you 3 days or more because they don't make a promise of that. So if you're planning to move data over or do a backup process of your data, know that the request may take 3 days to process. But that's a side note. Okay, unless there's anything else that you all want to cover, I think it's time for AI and science. Okay. So today's AI and science story is about something that sounds deceptively simple, but could change how an entire scientific discipline works. Researchers at UC San Diego have built an AI agent that they're calling Zephyrus. They can answer plain English questions about weather and climate data. That might not sound revolutionary at first, but to understand why it matters, you have to understand the problem it's solving. So right now, if a climate scientist or meteorology student wants to ask a question like, what was the average wind speed over the Gulf of Mexico last Tuesday? They can't just, ask. They have to write code. They have to know which data set to pull from, how to query it, how to format that output, and how to interpret the results. The barrier of entry isn't the science, it's the data engineering. So weather and climate science sits on top of some of the most complex, high-volume data sets on the planet. We're talking about constantly fluctuating streams of temperature, atmospheric pressure, humidity, wind speed, precipitation, all collected by surface balloons, satellites, radars, ocean buoys, ships, and aircraft. Making sense of all that data has always required specialized technical skills that have nothing to do with understanding the atmosphere. So what the UC San Diego team did is build an AI agent that acts as a bridge. So Zephyrus takes a natural language question in plain English, translated into code, queries the relevant AI weather forecasting models, retrieves the data, runs the analysis, and gives you back a plain language answer. The researchers, including Duncan Watson Paris from Scripps Institute of Oceanography and Rose Yu from Department of Computer Science, described their goal as lowering the barrier to entry to analyzing critical data. They specifically want students and early career researchers to be able to interact with these data sets without needing years of coding experience first. As you put it, Zephyrus is a crucial step towards creating AI co-scientists that dramatically lower the barrier to entry, allowing students and researchers everywhere to access and reason without critical weather and climate data at unprecedented speeds. Now, it's important to be honest about where Zephyrus is right now. The team reports it performs well on basic and intermediate tasks, but it still struggles with complex multi-step queries. This is a first-generation tool, not a finished product. They're presenting it at the International Conference on Learning Representations, the ICLR, in Rio de Janeiro this April. But here's why this story is bigger than one research paper. Zephyrus arrives at a moment when AI weather forecasting itself is going through a revolution. Just last month, the NOAA, the National Oceanic and Atmospheric Administration, deployed a new suite of AI-driven global weather prediction models into operational use. Their system, called AIGFS, can produce a 16-day weather forecast using just 0.3% of the computing resources of the traditional global forecast system. And it finishes in about 40 minutes. To put that into perspective, the traditional system requires vastly more supercomputer time to produce essentially the same forecasts. All right. The system was built on Google DeepMind's GraphCast model, then fine-tuned with NOAA's own global data assimilation system data. That additional trading with NOAA's data improved performance, especially when using GFS-based initial conditions. And it already shown the results. Significantly better tropical cyclone track predicts at longer lead times. The trade-off is that intensity forecasting still needs improvement, which future versions will address. But for track accuracy, which tells you where the hurricane is going, the AI system is already outperforming the traditional model.
Yeah. We are with Yaro. Wow.
See if I can get through this. Excuse me. Separately, researchers at the University of Washington published a study showing something even more ambitious. They built an AI model called DLE-SIM, that can simulate 1,000 years of Earth's current climate in just 12 hours and running on a single processor. The same simulation on a state-of-the-art supercomputer would take approximately 90 days. And the model just didn't run fast, it ran well. The researchers compared its output to the 4 leading models from IPCC's Coupled Model Intercomparison Project. Oh, excuse me, I'm so sorry. Which is the gold standard physics-based climate model that run on supercomputers and inform the Intergovernmental Panel on Climate Change. The DLE simulated tropical cyclones and the Indian summer monsoon better than those leading models. In mid-latitudes, it compared a month-to-month and year-to-year weather variability, at least as well, including atmospheric blocking events. Those are the ridges that keep regions stuck in heat waves or cold snaps by deflecting incoming weather systems. The lead researcher, Dale Duran, frames the tool's purpose this way, helping scientists answer whether a given extreme weather event is the kind of thing that happens naturally within our current climate or something that defies the odds. When we talk about 100-year storms that seem to happen every few years now, this is the kind of tool that helps determine whether the climate itself has shifted. Meanwhile, at Boston University, climate scientist Elizabeth Barnes, the university's inaugural Dalton Family Chair in Environmental Data Science and Sustainability, is working on a complementary piece of the puzzle. Her focus isn't just on making AI predictions better, it's on making them trustworthy. So Barnes works on explainable AI, cracking open the black box to understand how the models learn from data and quantifying how much certainty we should attach to any given prediction. As she puts it, uncertainty quantification is huge in earth sciences. We do a lot of predictions. You can think of it as weather forecasting, but we go out years to decades into the future. We don't know exactly what's going to happen, so uncertainty has to be a part of what we produce. This matters because the AI model that gives you a confident wrong answer about next week's hurricane track is worse than no answer at all. The ability to say, here's our prediction, here's how confident we are, and to explain why is what separates useful tool from a dangerous one. Okay. So, with all of these examples, what you have is a convergence across multiple fronts. AI weather models are getting dramatically more accurate, outperforming physics-based models that took decades to develop. They're getting dramatically faster, from 90 days on a supercomputer to 12 hours on a single processor. They're getting dramatically cheaper. NOAA's system uses 0.3% of the compute of the system it's supplementing. Researchers are working on making the models explainable and trustworthy and not just fast. But all of the capability is only useful if scientists can actually access it and interrogate the data it produces. That's the gap Zephyrus is trying to fill. Instead of writing code to query a data set, you ask a question in English. Instead of spending hours on data wrangling, you spend your time on the science. So, the researchers see meteorology as a test case for something much broader, weather prediction. They know is a perfect proving ground because it combines large complex data sets that change over time with the need to reason about those data in plain language. If it works here, the same approach could work in genetics, material science, epidemiology, any field drowning in data that's hard to access. As Watson Paris puts it, we want to increase the speed in which we can reason about multimodal data and learn about the Earth by making it easier for students and young scientists to interact with different data sets. The tool isn't there yet. It handles the basic and intermediate queries, but stumbles on complex ones. But the vision that you should be able to talk to your scientific data and have it talk back in a language you can understand is one that could reshape how research gets done across the sciences. And the timing is right. The AI models generating the data are ready. The computing infrastructure is ready for the most part. What's been missing is the interface between the scientists and the data, and Zephyrus is the first step towards filling that gap. So that is your AI in science story. AI in weather prediction and weather science seems to be moving along at a steady clip there. Zephyrus's original paper, I think, came out in October of last year, and now they've moved on to presenting their actual model and their program in April. So not a lot of time has gone from initial release of the paper to putting it into circulation, if you pardon the pun.
I like the general conclusion that this is the development of the ability to talk naturally to a data set that's very complex and changing continuously. It's a more natural interface, obviously, for humans to have an ongoing conversation about something in order to develop understanding and action. And I think broadly that this beautiful example of how we're at the edge of the application of AI to really complex data in weather forecasting is really an analog for what has happened in the AI era since the emergence of ChatGPT-3, which is now you can talk to the computer and it's a conversational dialogue. And you're now with the latest frontier models, you're talking to a computer that is much, much bigger and more knowledgeable than anything we imagined before. The training that can become condensed into a single frontier model of only 1 trillion plus parameters is astounding. The level of knowledge and now reasoning capability that's packed into that you can speak to naturally. It can speak back to you in whatever style or language you ask it to. That's amazing to me, and I'm really happy that I got to live to experience it.
Yeah, it's true. Well, all great topics that we've covered today. And if you want to continue that conversation, please join our community at dailyaishowcommunity.com to continue that conversation and to share all of your ideas. We're going to wrap it up for today. So I want to thank everybody who joined us in chat and everyone who's just watching a little later. You can always catch us Monday through Friday, same bad time, same bad channel. Please make sure if you've enjoyed any of this, please make sure to click the things that make the dings. And remember to keep your minds and your hearts open. Aloha.